And so now let's move on to some examples. We have all the tools of the game. All right. So in example 1, at the state fair, you can play Fish for Cash, a game of chance that costs $1 to play. You blindly fish out a card that has a dollar amount that you have won from a giant fishbowl. The game has these probabilities of winning posted on the wall. Is it worth playing this game? So here we see, okay, here are the winnings you could potentially earn. You could win from $1 all the way up to $900, right? And here are your chances of winning. So you have 1 out of 10 chance of earning back your $1, right? But, and you have 1 out of 120,000 of winning $900, right? So getting a lot of bang for your buck, right? But is it worth really playing this game? Well, I've put all of this information on the example 1 tab, right? So these are the winnings, and I've just once again I've put them in here, and Excel has changed it into decimal form. Well, the first thing you want to do is check whether all of these probabilities actually add up to 1, right? Because remember, these are just posted on the wall. You don't know if they're telling you the whole story, right? So let's sum these probabilities up, and make sure that we've covered the entire space of winnings and probability of those winnings. These probabilities only cover 22% of that probability space, right? And there's a probability of 1, right? 100% is the total. So let's think. What must be missing? Well, I think the game probably doesn't advertise that you have the probability of winning nothing, right? So there's that probability, and they're probably just not telling you. So let's see. I am going to take all of this and add a row here. And in this row, I'm going to put 0 as the potential winnings, right? And the probability of getting 0 should be, there we go, should be 1 minus the sum of all the rest of the possible outcomes, right? And that's almost 78%. So you have a high likelihood of winning nothing, right? But once we do this, if we add up all of these, including the 0 one now we should have a sum total of 1. And that's good. We want that. Because this shows us this is now a complete probability distribution of the random variable winnings. Okay? All right. So what is the contribution of each of these winnings to this expected value? Over time, or over many, many plays of this game, what is the average winnings, right? Well, let's look at each one's contribution. And then multiply that all out. And then we sum these up. So when we look at the sum here, we see 60 cents is the expected value. Even though, there's this chance of winning $900, that's way more than 60 cents. It turns out that on average, if you play the game over and over and over and over and over, the average winnings is going to be about 60 cents. Well, you can win 60 cents on average, so the expected value of winnings, so maybe I'll put it as W, or, otherwise we could write it as mu of W, right? This is 60 cents. Is it worth playing this game? Well, it does cost you $1 to play the game, right? So if you play the game over and over, let's say you play the game 100 times, right? That's going to cost you $100, right? But over time, if you multiply this by 100, right, you're going to you're only going to win $60 for every $100 that you spend, right? So that's not really worth it. Over the long haul, you're going to be losing money. Now, expected value, I should say one thing. It doesn't matter that much if you're just going to play the game once, right? It's not going to tell you whether that card that you pick is going to be 60 cents. Because remember, there's no possible way you could earn 60 cents. So this is not what that means. It's probably very likely to be 0, right? Because that's 79%, right? 4 out of 5 times you're going to be drawing 0, right? So it's not about any one particular turn. And so you might think, oh, that's sort of useless, right? But actually it's not. Flip yourself around and put yourself in the seat of the guy who owns this game, Fish for Cash, right? You want to know the expected value if you're the owner of the game, because you want to know, on average, like all these different people are going to play, are you going to be losing money at the end of the day, or are you going to be raking it in, right? And what the owner of this game would say is, this is a good game, because if people play, even though I will lose 60 cents for every dollar, roughly, on average, I'll be gaining 40 of their cents, right? So that's my profit. So, this isn't really for just single people. Like, we're not trying to predict single events, but we're trying to predict events over time and over many, many examples.